Number 5 asks us to find the first three terms of the Taylor series for tangent x centered at pi over 4. So we know that in general, tangent x can be written as the sum from k equals 0 to infinity of, we take a bunch of derivatives of it, evaluate it at the center, which is pi over 4, and then that's divided by, that's a 4 there, that's divided by k factorial times x minus pi over 4 raised to the k power. And so all I'm doing is writing out the first three terms, which are going to be these terms. When I put in 0, it's the 0th derivative at pi over 4, divided by 0 factorial, which is 1, x minus pi over 4 to the 0. So that's what I get there. And then it's going to be the first derivative at pi over 4 over 1 factorial times x minus pi over 4 to the 1. And then it's going to be the second derivative at pi over 4 over 2 factorial times x minus pi over 4 squared. And this keeps going, but that's all we're asked to find is the first three, so we don't need the rest of them. And you can see the only thing missing is I got to figure out that. I got to figure out that. The rest of it's all in there already. And I got to figure out that. So I just need my derivative and second derivative and my function evaluated pi over 4. So f of pi over 4, that's just tangent of pi over 4. And if you don't remember it, you can draw a triangle with an angle of pi over 4, which is 45 degrees, right triangle. So that one's also 45 degrees. And that gives you 1. So that's what's going to go there. Then I need a derivative. Let's find that derivative first. Well, derivative tangent x is secant squared. And so I need that derivative at pi over 4. That's secant squared of pi over 4. So I can use this same triangle. Secant, remember, is hypotenuse over adjacent side, using that as my angle. So that's square root of 2, but it's squared, so I get 2. And then I need the second derivative at pi over 4. Well, second derivative is going to require a chain rule. I take 2 times secant to the 1, and then the derivative secant, which is secant tangent. So it's 2 secant squared times tangent. Well, I've already calculated both of those values. So second derivative at pi over 4 is going to be 2. Remember, we just calculated secant squared to be 2, and tangent of pi over 4 is 1. So this is going to be 4. All right, so I'll plug those in. What I'm saying is the power series for tangent starts out like this. Remember, we said the first one's going to be 1 plus the second one. It's going to go right here. We got 2. So we're going to have 2 over 1 factorial. So that's 2 times x minus pi over 4. And the third one's going to go here. And it's 4. So we're going to have 4 over 2 factorial. 2 factorial equals 2. So this is just going to give me another 2. So this will be plus 2 times x minus pi over 4 squared, and this would keep going, but that was all we were asked to find. Okay, number 6, we're asked to use the comparison test to determine whether this converges or diverges. Well, we know that when we're using comparison test, we have to write down what we're comparing to. And I take the dominant terms of the top and the bottom. So that's 2 to the k over 3 to the k. And I have to know whether this converges or diverges. And I can see this is in the form of a geometric series. K equal 1 to infinity. This is 2/3 to the k, which is a convergent geometric series, because the r here is less than 1. Now that I know it's convergent, I just kind of draw my little schematic. I've got mine is convergent, meaning if you're thinking of it, it's sort of like area, which it's not area, it's point values, but it's convergent. So for me to draw a conclusion about this one, it's got to be underneath it, so that I get if this one's finite, then the one underneath it has to be finite. If this one were above, it could be finite or not be finite. We don't know, not based on what the green graph is. So taking this one, I can see that it needs, when compared to this 2 to the k, 3 to the k, what I need to verify is that the green graph is above that one, greater or equal, doesn't matter there. And so our standard trick here is to cross multiply. This would need to be true. Well, so we get that representation. We can see if I distribute 2 to the k to both these places, I'm going to have these things canceling out. There's going to be a 2 to the k, 3 to the k, and 2 to the k, 3 to the k. And so what I end up with from this is 1 on this side, k times 2 to the k, which is certainly a true statement. And these are reversible based on the k's that we're using. And so this one is true. So my blue graph here, my original series, is smaller than this convergent series. So the comparison test does imply that my original series converges.